Hey everybody, today we're going to do a few problems with graphing of linear inequalities. And this will seem very familiar to you if you remember how to graph linear equations. So let's go ahead and take a look at this. We have y is less than x plus 1. So first thing we need to remember is that if we see less than or greater than, our line is going to be a dotted line because it's considered not inclusive. And if it's less than or equal to or greater than or equal to, it's going to be a solid line because it is considered inclusive. Because basically, if it's one of these, the line would be part of the solution. Okay, so let's graph this like we would a normal linear equation. So if it was y equals mx plus b, we're going to follow the same rules. So our y-intercept is 1. Our rate of change is 1 over 1. It's positive. So there we go. That's going to be a dotted line. Okay. And now we're going to use a test point. So I like to use the origin if possible because plugging in 0 just makes our life a lot easier. So we're going to plug in 0 for our x and 0 for our y and see if we get a true statement. Now there may be a situation where the line is going through the origin and you can't use that because the test point needs to be on either side of the line. But in this case it's okay. In the event you can't use 0, 0, I would use 1, 1 or 0, 1 or 1, 0. Those are usually not bad. So y is less than x plus 1. Are you guys going out? I'll be right back, guys. Okay, so we use our test point, and we're going to rewrite this. So y is less than x plus 1. We're going to replace the coordinates, we're going to replace the variables with the coordinates of our test point, which is 0, 0. So 0 is less than 0 plus 1. And these are coming from our test point here. And 0 plus 1 is 1, so 0 is less than 1. Is that a true or false statement? Well, it's definitely true. So because this is true, that means this point is part of the solution, which means it's this side of the line. Okay? So any point in the shaded area would be part of your solution. If this was a false reading, then we would have shaded the opposite side. All right, let's try this other one here. So y is less than or equal to negative 3/5 x minus 2. So our y-intercept is negative 2. Okay? Our rate of change is negative 3/5. So I go 1, 2, 3, then down. So I went down 3, then right 5 because it's a negative rate of change. 1, 2, 3, 4, 5. I'm going to go up 3, 1, 2, 3, then left 5, 1, 2, 3, 4, 5. It's or equal to, so this is inclusive. It's because it's inclusive. Actually, I have a ruler. Might as well do that. Because it's inclusive, we're going to have a solid line. So the line is part of the solution. And for our test point, let's go ahead and use our origin because it's not on the line, so we might as well. Makes our life easy. So we're going to rewrite the inequality. We have y is less than or equal to negative 3/5 x minus 2. Let's replace the x and y with 0. So 0 is less than or equal to negative 3/5 times 0. Negative 3/5 times 0 is 0. And 0 take away 2 is negative 2. So this is stating 0 is less than or equal to negative 2. That's not true. Okay, 0 is greater than negative 2. So this is false. So because this is false, that means this is not part of the solution, which means this side is not the solution. It's this side instead. Okay. Let's try number 5. Our y-intercept is negative 2. Our rate of change is positive 6 over 1, so we're going to go up 6, right 1. So 1, 2, 3, 4, 5, 6, right 1. We can't fit another one. This is going to be a dotted line because it's non-inclusive. So something like this, I guess. Okay. And it looks like we can still use the origin. It's not going through there, so we'll label that as our test point. And we're going to write y is greater than 6x minus 2. 0 is greater than 6 times 0 minus 2. 6 times 0 is 0 minus 2, and 0 take away 2 is negative 2. Is 0 greater than negative 2? Yes, it is. That's true. So because that's true, we're going to shade towards the test point. So there you go. All right, let's try the back side here. Number 7. Our y-intercept is 5, so here we go. Our rate of change is negative 6/5, so we're going to go down to the right. 1, 2, 3, 4, 5, 6, then right 5. 1, 2, 3, 4, 5. And this is non-inclusive because it's just greater than, so it's going to be a dotted line. So here we go. All right, let's go ahead and use our test point here, which is going to be our origin. And let's rewrite this. So y is greater than a negative 6/5 x plus 5. And plug in 0 for x and y. So 0 is greater than negative 6/5 times 0 plus 5. And negative 6/5 times 0 is 0. And 0 plus 5 is 5. So 0 is greater than 5. Is 0 greater than 5? Absolutely not. That is false. So which means we're not going to shade toward the test point. We're going to shade the opposite direction, which is right here. Okay, let's look at number 9. Y is less than x minus 2. Our y-intercept is negative 2. So right there. Our rate of change is 1. So it's positive 1. So we're going up 1, up to the right 1, or down to the left 1. And it's going to be non-inclusive, so it's a dotted line. Okay, our test point is right here. And y is less than x minus 2. Plug in 0, 0, so 0 is less than 0 minus 2. 0 is less than negative 2. Is 0 less than negative 2? No, it is not. So because, this is not part of the solution, we're going to shade away from it. Okay, and we'll do the last one. So this is a good one to finish with because you'll see why in a moment. The y-intercept is 0, which is plus 0. Our rate of change is 1. It's positive because the number in front of x is invisible, but we know it's a 1. Okay. And this is inclusive, so it's going to be a solid line. Okay. Now we cannot use the test point we're used to using because it's on the line. So, and since it's inclusive, if we use 0, 0, I can tell you right now it's going to be a true statement. So let's use 1, 0. We'll use that as our test point. So our x is going to be 1, and our y value is going to be 0. So y is less than or equal to x. Our y is 0, but our x is 1. Is this a true statement? Is 0 less than or equal to 1? Yes, it is. It's true. Which means our test point is part of our solution. Therefore, we shade that side. Okay. All right, guys, let me know if you have any questions or if you want me to go over any of the evens on this activity. I'm more than happy to do that. I hope this clarifies any questions you have or answers any questions you have. All right, thanks for watching.